Okay, today we're going to talk about something called scatter plot. And so we've been working with one set of data, and we've been looking about, we've been determining all the things about a single set of data. For example, like what's the mean, median, mode, how we represented, what's the maximum, what's the min, what's the the quartiles. Now the idea in this unit is we're going to connect two pieces of data. So the idea is, so first of all, we're going to see if there's a correlation. So the word correlation, it refers to the relationship or association between two variables. It refers to the relationship or association between two variables. The idea is I'm going to collect two pieces of information from somebody or something. So, for example, in an example we're going to see in the video, I'm going to ask someone, A, how tall are you? And B, when you hold your hands out, what is the length of your arms? So I have two pieces of information from a person. Or what I can do is I can go to like a bunch of gas stations, and I can, get a certain amount of gasoline, how many gallons, and B, how much did it cost? So the idea is I want to see if there's a correlation between the first thing I asked and the second thing I asked. I'm not a connection. I'm not looking for causation. I don't know if how tall you are causes your arm length. I don't know, if, it might, the amount of gas you get gets, it depends on how much it costs. But I want to see if there's a connection, okay? And that connection is, we're going to see that in a graph. So let's take a look at the video. Okay, so here's our two set data sets. I asked a bunch of people, I said, how tall are you in centimeters? The height in centimeters. And I asked what their arm length is in centimeters. And I got two pieces of information from, 7 people. The first person said they are 136 centimeters tall, and when they hold out their arms, it's 136 centimeters. 140, 149. Maybe the idea is, does one affect the other? Is there a connection? We don't know, but I asked someone two pieces of data. What we're going to do is we're going to make this X and Y. So, for example, column A is the X, and column B is the Y. So we actually have coordinates, and we can make a scatter plot. Now, up until now, we've been training you to think that like Y depends on X, but now we're changing the rules a little bit. Although these are coordinates, X and Y, we don't know if they're connected, but we can see if there seems to be a correlation. So what we're going to do is we're going to use Google Sheets. We're putting the information in. Then we go to the right, insert chart. And then we go to this over here. We're going to look at scatter chart. The first one, okay. You can see here the data range was from A1, so they include the title down to B8. The x-axis I'm going to make height, and the series, which is the y-axis, we're going to call arm length. Once again, it does not. We're not in this unit. We're not implying that arm length depends on height. We're just saying if with these two sets of data I created a bunch of points, is there we're looking for a connection. So, what we see here is this is our scatter plot, and we seem to know there seems to be a connection. It seems as height increases, arm length increases. Once again, we don't know if they cause each other, but there seems to be a correlation or a connection. And so what we're going to be doing is you're going to be drawing a line of best fit. So let's go to insert chart, back to insert chart, scroll down, go to customize. Let's go to series. Scroll down. We're going to put in the trend line. And so we see we have a line. Well, we've studied this. We can actually find the equation of that line, but we're not going to. The computer is going to do that for you. So we're going to scroll down a little bit more. We're going to click down label, use equation. So we actually have an equation of that blue line, 9.75x plus 6.44. We have a slope and a y-intercept. And we're going to look at the last thing, because if you notice, all of the points are not on this line. And we kind of like drew a best line through it. The question is, how well does all this data fit near the line? And we're actually going to use this right here, show r squared. We're going to be looking at that number in another unit. And so the idea is, let's see, so that's the idea. So you're going to take two pieces of data, you're going to put them in the computer or your calculator or sheets. You're going to, the first column, second column, you're going to go to once again, insert chart, and then you're going to make a scatter chart. Okay, excellent. Okay, so we watched the video, and so we had these scatter plots. So you saw that let's see. So the idea is, so let's start. So we saw our scatter plot. We had a bunch of data, and we plotted it, and we're looking at this picture. Two things we're interested in. This direction. So either the scatter plot looks like this, and we call this positive, or our scatter plot is going to look like this, and that's negative. And the idea here is that as x increases, y increases. I'm not saying that x causes y. We're just saying as my height increased, my arm length increased, or something like that. Or I don't know, the number, as the number of days a city had sunny days, umbrella sales fell. We're not saying one causes the other, but there seems to be a connection or a correlation. Next. Now, and once again, I keep saying, it doesn't cause. In biology, you're interested in like, does sunlight make plants grow? Does adding this chemical make, kill the environment? Does smoking cause cancer? Like stuff like that, where you're not only interested, you had a connection, but now next year in this class, we're going to say, can we figure out mathematically, does X cause Y? But not this year. Next thing we're going to talk about is strength. Because what you're going to see is, let me move this down a little bit, you ever have a couple of relationships. So you might see, three scatter plots which are all positive, but you're like, you know what? It doesn't look like, they're different. And so, can you see the dot? Yeah. So the idea is, in the video, we put a line of best fit in. Well, if you notice, I can put the same line of best fit in all three of these, right? It's technically only, but you're saying, Mr. Adler, that's not the same. Well, they're not the same. So the idea is with the strength. So this is going to be a strong and positive. This is going to be moderate and positive. And this last relation is going to be considered weak and positive. In all three cases, you're like, no, as X increases, Y increases, but it's really strong here, it's kind of moderate here, it's really a weak relationship. And the same idea is, we can make these, obviously we can apply it to the negative. So let me erase this. You can write new diagrams. Same idea. We can have this is very strong. This or whatever these data points are, it's very strong. The line of best fit. Here, I might have a relationship. It's kind of strong. It's more moderate. It's the same line, but you know what? These points seem to be really close to the line. These points are, it could be a little closer. It's still moderate. What's going on here? Yeah, it's once again, it's so moderate, but that's kind of weak. It's still negative, right? They're all negative. Negative, 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 but it's strong, moderate, and weak. Let's see. Okay. What else do we want to talk about? What else do we want to talk about before we go? Let's see. Don't worry about the outliers. Don't worry about outliers. So maybe you've collected data. Hopefully you've experienced this in your science classes. You've collected some data. It's really strong. You said, "Oh, I think as X increases, Y increases," and then you kind of have like this point up here, and you're like, "Well, does that screw up my my data line?" Well, it will, but the idea is if we can determine it's an outlier, and you're not going to be getting outliers, the idea is you can ignore. That's why you can ignore the outliers, because actually, if you don't ignore the outlier, it's going to pull the line a little bit closer to it. That's why you ignore the outlier, and we get a really strong negative relationship. And once again, the idea of causation. I don't know if X causes Y to decrease. I don't know if it causes. Once again, I have a bunch of points. It looks like I could draw a line through it. I can get the equation of that line, and then we're going to do some other thing called interpolation and extrapolation, and that's basically it.